Good afternoon, good morning, good evening, good whatever time it is at your place. Today I'm going to talk through a comparison project that I did for the company that I currently work at called Sync ICT. Basically, we wanted to look into what is it like deploying a technology stack to predict essentially an MLops project that uses a paid approach. So in this instance, we're going to be looking at Databricks versus a fully open source framework. In this instance, it's going to be Kubernetes and Minikube, which is the local version. And yeah, I'm going to draw some comparisons, kind of talk through the different frameworks, look at the project that we are using for the comparison, look at what I think the differences are between the paid and the open source, kind of discuss, and yeah, we'll have a quick price comparison of hosting the approaches. So let's get started, shall we? So yeah, as I said, Databricks workspaces are the paid one, and Kubernetes is the free version, open source. Databricks in this instance is using something called Delta Lakes to house their data, building a kind of meta layer over this using Hive and Hadoop, which is then actually what you interact with. So that's where you can have your SQL and your Python, PySpark code interacting with your backend. And then uses its own kind of Databricks MLflow format, to go from data, training the model, cross-validation, kind of showing you what's going on with your model, helping you choose, hosting the backend, and hosting the backend, I guess, so where all the data is, but also MLflow, which is the open source project that Databricks employees created, but Databricks uses the backend for all of this stuff. Using this to host the model as a REST API, and then using this as an endpoint to get your predictions from. Creating Streamlit dashboards on both ends actually. So Streamlit here and Streamlit here, looking at the data and the predictions that come out of it. So I say quote unquote monolithic. I mean, it could be argued that because it's a Delta Lake, it is somewhat distributed, but I mean more the sense that everything that you do using this framework is just the Databricks kind of workspace and thus workflow. Kubernetes is distributed in comparison. It uses what are called microservices as the kind of main architecture, essentially lots of little blobs kind of interacting with each other to give the end user a specific experience you're looking for. This uses Kubernetes, of course. I'm using Minikube on a Mac OS system, building images with Docker. I'm hosting the data myself locally in a MySQL database, and then using Python, XGBoost, sklearn to train and test the model. Fast API is then the free open source version of the REST API endpoint that you kind of get included with MLflow and Databricks. And then once again, Streamlit is the dashboard of choice. I am doing all of this locally, but once you've created all of this, you could do you could push everything to, let's say, the Azure Kubernetes service or the AWS or GCP equivalent. Also, I have made 2 complementary videos to this one, showing the full process of deploying each of these things and looking at the output and how it's done, basically. So I won't be showing demos in this. If you want to see the demos, then you'll need to check out each of those videos respectively. This is just kind of my musings and experience. So, what is the project exactly? We are going to grab weather data, specifically temperature and the amount of rain of a day, and using this data to predict the amount of time the train services in the Netherlands specifically are delayed for. So we'll get data in centigrade, and I believe it's milliliters per meter or something like that. I need to look at how rain amount is calculated. But this data on a daily basis, so the temperature is then aggregated to min, mean, and max. And the rain amount is just the summation, so total amount of rain. And using this to predict the amount of time in minutes that all trains are delayed by in the day. So yeah, we're training on historical data from a company that are very nice to keep track of all of this, called Rijden de Treinen. This is data that goes back to 2011, so from it's 10 years, so 2011 until 2021. And then using historically processed weather data, so creating the mean, min, max, and sum of temperature from openmeteo.com, so the corresponding 10 years, using those as the features, and then doing a grid search cross-validation, so taking various chunks, training on one, predicting on the other, and then hyperparameter tuning the model to give the best results possible, with the best being based on the root mean squared error between the prediction and the actual values of the time train, the amount of time the train is delayed by. And then following this, hosting this model somewhere so people can send requests and get the predictions back. This is then via Databricks REST API or Fast API, depending on the approach. And then creating a dashboard to show the weather and the comparing prediction, because NS reports its own, NS is the Dutch train system. They report the amount of time they think, or like they scheduled, let's say. No, that's not true. They report the amount of time due to the amount of delay time due to unforeseen circumstances. So we can have our true versus predicted in our dashboard as well. Cool. And so this is the paid framework. I should have mentioned the backend I'm using happens to be Azure, but Databricks is a like third-party service, so you can host the backend anywhere. I've just been doing a bunch of Azure courses at the moment, so my knowledge of Azure is pretty fresh at the moment. But you can, of course, use Amazon Web Service or Google Cloud, GCP. Forgot what the P stands for. Platform? Google Cloud Platform? Yeah, Google Cloud Platform. So this is what Databricks themselves think is a good approach to doing machine learning operations, MLops. This is the workflow that they suggest. Having CI/CD via GitHub or Azure DevOps, keeping your data is in a quote-unquote data lakehouse, using something that I believe Databricks also created, Delta Lake, DELTA Lake. Essentially having lots of blobs of like various files that you care about, and then having this meta layer, this quote-unquote feature table, which you can then use to interact with your data. And then having three different environments: the development environment, the staging environment, and the production environment. Development obviously is to grab your data, look at what it looks like, grab interesting features out of this, so think feature engineering, feature selection, training your models. Once this has happened, they suggest pushing it to the quote-unquote staging environment, which is where, using actual data, you continue to double check that everything is hitting the tests that you're expecting that will hit. So the continuous integration tests, think unit tests, think I forget the word that I need, but where the model that you've created interacts with the whole like platform. So let's say you have a front end that talks to your middleware through your talks to your backend through your middleware, and you have included your model in your middleware, and it's not in the format of what the front end is expecting. Then you'll have problems, of course. So that's the sort of quote unquote integration test that they're thinking about. And then if that goes well, then you can put into the production environment. But yeah, this is the full approach that they suggest. Because this is just a quick demo, the thing I did was basically only look at the production environment, which then is a selection of, model training again, because now we're actually using production level data, pushing it to a model registry, which then includes the metadata of like, what was the environment that was used to create the model, what features were there, which were good or not, based on feature evaluation techniques. Think SHAP is a big one that I see a lot at the moment, SHAP values. What else? The corresponding RMSE values of the various different models that are there. And then kind of methods of how to choose them. Also using the feature table from your data sets from before. And if all of these pass all of your continuous integration checks, continuous development checks, then a model is pushed from staging to production, and then once it's in production, then it is just fully live in your main platform. And then at this moment, you want to be able to serve your model using a something, either your batch or streaming method, or serving it as a online thing, so an endpoint where external parties, or like within your own setup, external software, external, think front end of your app to middleware of your app, where this can then send data and then get predictions as the outcome. In our instance, the middleware is the model and the front end is the dashboard. And then once it's live, you can then monitor how it's doing. Think data drift, think model degradation. These are the sort of things you should be looking at when monitoring. And then what's very nice about Databricks is that they have a lot of add-ons for them. Yes. And then here's the open source version. Because Kubernetes is just a means of creating a microservice architecture, none of what we just mentioned really is inherently included. You will need to do this yourself manually. So think using GitHub for the various different environments. So you'd have a quote-unquote development environment, your staging environment, and your production environment in GitHub. And then think using GitHub Actions to deploy your CI/CD pipelines, which you would then need to do for each, not each of these, because this is an API that's hosted by NS, and this is an API that's hosted by OpenMeteo. But each of the SQL that you set up, the model, and API endpoint and dashboard, you would need various CI/CD methods to be incorporated. As I said, none of what we just mentioned comes out of the box here. So I think versioning, model comparisons that are easily accessible. You could incorporate it using MLflow yourself manually, but it is an extra thing to kind of think about. Because it uses a microservice architecture, if something goes wrong in one of these things, you don't inherently lose the other parts of the service. So in this instance, if the XGBoost if the model itself was not running correctly, the fast API wouldn't inherently go down. I mean, the main thing that you care about is the prediction, so it's not ideal, but it wouldn't inherently break there. And because you're calling your front end is calling not only the model predictions but the various different endpoints. If one of those endpoints goes down, you don't inherently lose your dashboard. You just lose certain functionality of it. So this kind of distributed microservice approach is sometimes considered somewhat more resilient. I don't know. It's open to discussion, I guess. Yeah. So, what did I personally find what was my experience? Basically, this is essentially the discussion here. Bear in mind, I'd never used Databricks. I'd used it a little bit, but not too much prior to this. And Kubernetes, I was learning as I was going. I'd used Docker before, but Kubernetes was not really something I came across. Background is more a data science, data engineer more than a developer, in the sense of making large ecosystems or architectures. I found that Databricks was quite rigid in the sense that you had to follow their pipeline. Let's say maybe you don't want to do feature engineering in the specific setup they have, then you're a bit kind of screwed. Or if the ML flow thing that they have doesn't work very well with, let's say, a more esoteric model that you've created, that will be a bit of a pain. However, the learning curve is very, very quick. Their Databricks are very, very good at their documentation. It is not difficult to work with at all, which is very nice. There's tons of add-ons. The model registry, essentially listing all the metadata and the models that you have, running various experiments and making it very easy to compare using their ML flow package that they created. Although this is open source, so you could do this manually yourself later if you wanted to. The deployment, it's very nice that they have a full pipeline for you to push your model to the rest of the world if people want to use it. I noticed this later, but the Azure and AWS has SageMaker, and I'm sure GCP has its own version. But a lot of these big cloud platforms are essentially slowly making their way to the level of Databricks. And then maybe in the future Databricks will die unless it remains incredibly innovative, because the cloud providers themselves are beginning to create these environments themselves. So if you look at the difference between Databricks and Azure Machine Learning, and like Synapse and stuff, and for AWS it's AWS SageMaker, you will start to see that they do a lot of very similar things. So then you've kind of got to think, are the extra bits that Databricks provides, are they more, is it worth going to them if you're already used to a specific environment? Up to you. With Kubernetes, is very, very flexible. Basically is just a way of creating a architecture, and anything that you put in a Kubernetes pod could be anything, as long as it can be Dockerized. So it doesn't mean that you're inherently locked to a specific language. Oh, I should have mentioned Databricks. Maybe they're going to improve this in the future, but I think they only support SQL and Python. I need to double check that. Maybe they do R as well, but it's as the spectrum of languages goes, it's quite restricted in that sense. Whereas with Kubernetes, as long as it can be Dockerized, Kubernetes doesn't mind. So you could have one microservice running in Rust and one microservice running in Go, and as long as they kind of reveal standardized endpoints, then it doesn't matter. The learning curve here was a bit harder. The concepts in Kubernetes are not too complex, but the documentation is often a bit messy, And yeah, I had experiences where the example code they had just didn't run because it was out of date. But yeah, other than that, not too bad. Yes. Oh yeah, and because Databricks, a lot of the back end of Databricks being open source, you could just make your own version of this if you really wanted to. So Delta Lake is like the main thing. It's the method that Databricks uses to have its data lake. So Delta Lake is the service. I think it's a package or service. I need to double check. But in any case, it's open source, so you could use that, and it uses a lot of Apache stuff. Hive is the metadata layer that goes between your blobs and your code, which is then open source, so you could reuse that. MLflow, the MLops package, they themselves have made open source, so you could also do that. And Fast API is a nice way of emulating the REST API that comes out. PySpark is the main backend that's being used, which is also open source. And in theory, Kubernetes is somewhat less expensive, but I mean this will vary depending on your usage of everything. I did a very simple price comparison between ways of Azure hosting for all of these things. So if you used Kubernetes in the same way that we have with just a standard cluster, then yeah, it's 81. So basically, doing everything locally and then pushing the final environment or framework to a Azure Kubernetes service, then yeah, you'll end up around monthly €81 or so. This will obviously expand if you use it more, if you have if your compute instances are large, etc., etc. Then you have like Azure's own version of Databricks, like their approximation of it, called Azure Machine Learning, which in theory is then a bit less still. And then Azure Databricks itself is then $390. So yeah, it has its ups and downs. As with everything, both approaches are subject to preference and use, and like whatever your current situation is, may be more or less applicable. Hope you found this interesting. Please check out the setup videos for both approaches. I will link them somewhere, or maybe they'll be below this video. But yeah, it's interesting to see the setup approach for Databricks and the setup approach for the Kubernetes version. Yeah, and thank you for watching. I have been James Twose. This is my GitHub, James H. Twose. It's somewhat active. You can also find my LinkedIn and stuff if you care about that. Thank you.